Okay, let's do some mixture problems. So mixture problems are really important. You might see them in chemistry problems, anything with allied health, medicine, nursing, anything like that. In the food industry, you may see a mixture problem as we're going to mix two different kinds of nuts and they cost different prices per pound, and we're trying to make a bag of mixed nuts and we want to figure out what the new price should be. So that's an example of using a mixture problem in that way. So let's think about making it actually like a solution. A solution is made up of a solute dissolved in a solvent. Okay, and we know that volume of the solution times the concentration of the solute will give you volume of the solute. Okay, so let's just think about what we have here. So if you have some container with some liquid in it, and maybe you have 10 milliliters of solution, and maybe in that solution there's something dissolved, some solute dissolved. Okay, so maybe this solution has a concentration of 50% salt. Okay, so that means 50% of the solution is salt and 50% is water. Okay, does that seem reasonable? So 50% of the solution is salt. We can do this in our heads. 10 milliliters, 50%, that's half. That means we have 5 milliliters of salt. And then we would have 5 milliliters of water. I'm going to write H2O the way we do in chemistry. So, but what you're really doing is you're saying you take the volume of the solution, 10 milliliters, that's the volume of the solution, and then we can multiply that by the concentration of that salt. Our solute is what's being dissolved, in this case it's salt. The concentration of the salt is 0.5, and then if you multiply, you're going to get the volume of salt in that container. So we see 10 times 0.5, we do get 5 milliliters of salt. So I think if we talk through it and we use easy numbers, you can understand this, but this is the process we're doing. Okay, so I could change this up. I could say maybe this solution is 20% salt. So that means you would have the volume of 10 milliliters, the volume of the solution, times the concentration of salt is 0.20. And if you multiply that, you get 10 milliliters times 0.2. You see you have 2 milliliters of salt. So hopefully that doesn't come as too much of a surprise. We're just looking at what percentage of the solution actually is solute, which is the thing that's being dissolved. But when we make a solution, often we mix two different solutions. Okay, so if you're mixing something, if you have solution 1 and you do the volume of that solution, and then you multiply by the concentration of whatever solute you're talking about, by this formula, we will be able to figure out what the volume of that solute is in solution 1. So let's say for our example, this is milliliters of salt. But maybe I'm mixing that with another solution. Solution 2, if I look at the volume of that solution, and I look at the concentration of solute in that solution, again by the same formula, I'm going to get the volume of solute here. Okay, so let's just use the numbers I had. So if I end up doing this, and let's say my solute is salt, so what if I had 5 milliliters of salt from this calculation in solution 1, and then I add that to the 2 milliliters of salt, maybe this was solution 2. I didn't say it earlier, but I used the same volume. Volume was 10 milliliters. Concentration of salt was 20%. You see, well, okay, if I have 5 milliliters of salt, and I add 2 more milliliters of salt, I should get 7 milliliters of salt. So that's how we're going to do this. Our new solution also will be considered as the volume of the solution times the concentration of the solute. Let's do a mixture word problem. A nurse has 250 milliliters of a solution that is 12% alcohol. How much pure alcohol must she add to increase the concentration of the solution to 18%? We think about a solution. We have 250 milliliters of solution, and 12% of it is alcohol. So 12% is alcohol, and then 88% is something else. So this would be like the alcohol, and this would be like the rest. So the solute in this example is the alcohol. Okay, we're probably talking about isopropanol or isopropyl alcohol, not drinking alcohol. So a nurse has a solution, and then what is she going to do? Well, she's going to add something to it, right? She's going to add pure alcohol, and she's going to make a new solution. So solution 1 is going to be her original alcohol solution. And then she's going to add something to it. She's going to add pure alcohol, and she's going to get a new solution. And I already wrote new solution, but there you go. So we're going to go piece by piece. First solution is the original alcohol solution. We need the volume, and we need the concentration. And we already know the solute is alcohol, so concentration of alcohol. So we're going to go piece by piece. A nurse has 250 milliliters of a solution that is 12% alcohol. So do we have the volume of the alcohol solution anywhere in here? Yep. 250 milliliters, that is the volume. So 250 milliliters. And now we need the concentration of alcohol in that solution. So that's where this part's going to come in. 12% alcohol. But I can't put 12% here yet. I'm going to have to tweak it. 12% needs to be changed if I'm going to use it in a mathematical calculation. So right now it's 12 with a decimal place after the 2. I'm going to take this decimal and I'm going to move it 2 places to the left. So the concentration is going to be 0.12. Okay, then we're going to add something to it. How much pure alcohol must she add? So I'm going to circle this part. How much pure alcohol must she add? That's what I'm looking for. That talks about the alcohol she's pouring into this solution. Okay, do we know the volume? Volume? No. How much? That's the volume. We don't know. Anytime you don't know, you're going to use a variable. We're going to use x in this case. You're going to use a variable, right? Okay, do we know the concentration of that solute? Concentration of alcohol. She's adding pure alcohol. How much pure alcohol is in pure alcohol? All of it, right? Okay, so if it's pure alcohol, we know pure alcohol is 100% alcohol. So we have 100. There's a decimal place after that 0. We move it over 2 places to the left. So we're going to say 1.00 is the concentration. Okay, 1.00. Okay, so hopefully that is good. We put a plus in the middle. So now we have the original solution. She's added some pure alcohol. She's going to get a new solution, right? Well, what do we know about the new solution? So the new solution, we need the volume of the new solution. If you go back through the problem, does it talk about the volume of the solution anywhere? No. It says we're going to increase the concentration of the solution. It gives us a percentage, but nothing talks about volume. So let's just think about this, talk it out. So what if I have 250 milliliters? That's the first solution. And we're going to add some more liquid to this, right? I'm pulling a number out of the air. This has nothing to do with the problem. I'm just making an argument here. So what if we added 20 milliliters of solution 2? Well, if you have 250 milliliters, and then you add 20 milliliters, your new volume is going to be 250 plus 20 is 270 milliliters. Okay? We don't know what we're adding, though. Maybe it's not 20. Maybe it's 47 milliliters. So then you would have 250 plus 47 as your new solution. You'd have 297 milliliters. So we don't know the volume that we're adding, so I just pulled some numbers out of the air. But we know we have 250. We're adding more liquid, right? So our volume is going to be the 250 original milliliters, plus we're going to add X more milliliters from here. Okay, so then we ask for the concentration of the solute. We're going to increase the concentration to 18%. So the concentration is going to be 18%. Again, 18%. There's a decimal place after the 8. We're going to go 1, 2 to the left. So this is 0.18. Okay, so now we have an equation to solve. I'm going to erase this. I'm going to drop the units, but you see this is milliliters. The volume here, I didn't write it, but X milliliters. So milliliters plus milliliters. Okay, yeah, that's going to be a new volume of the solute. So this will be milliliters of the alcohol. And over here we have milliliters. So the units are appropriate. I'm going to drop the units just so we can solve this. So 250 times 0.12 plus. We usually don't write it like this. X times 1. Usually we say 1 times X. I think we put the number first. Okay, and then we have 250 plus X. That's what this is, right? If I drop the units, 250 plus X times 0.18. But you're probably more comfortable if I switch the order here using the commutative property. Multiplication is commutative, which means I can flip the order. For example, 3 times 7 is the same as 7 times 3. So it's okay if I write this as 0.18 times 250 plus X. And now we're going to solve. So we're going to multiply 250 times 0.12. We get 30 plus X equals. And now we're going to distribute. We're going to do 0.18 times this value in the front and then 0.18 times the back. So 0.18 times 250, we get 45. And then 0.18 times X is 0.18X. Now we're going to get all the X's on one side. So we're going to subtract 0.18X from this side and bring it over here. Okay, so those are going to cancel. We're going to have 30 plus X minus 0.18X equals 45. Now subtract 30 from both sides. X minus 0.18. So really this is like 1 minus 0.18. So 0.82X equals what, 15? And then we divide by 0.82. So X is 18.2927 milliliters. So this nurse needs to add 18.29 milliliters of pure alcohol to increase the concentration of her solution to 18%.